All right, so let's talk about the physical properties of alkenes. So you might remember in a previous video, we've talked about the physical properties of alkanes. So alkanes are just a single carbon chain, and they can come like that, or they can come like that with branches coming off of them or something. Really, anything that just has carbons and hydrogens is an alkane. An alkene, of course, the ene part just means there's a double bond. So any of these then could be turned into an alkene simply by adding a second carbon-carbon bond somewhere. And now we're dealing with alkenes. So you might imagine that compared to alkenes physical properties are roughly similar. So we learned that when talking about alkanes, cycloalkanes had roughly higher boiling points compared to their straight chain cousins. Branched alkanes had slightly lower boiling points. And that's going to be true for us still. We just changed that letter, and those things are both still true. And then compared to alkenes generally have slightly lower boiling points. Than alkanes. So that's alkenes, slightly lower than alkanes. That's basically it. So here's a quick little example of what we're talking about. Here's hexane, a straight chain alkane with 6 carbons. It has a boiling point of 68.7 degrees Celsius. And we have 2 alkenes, of course. We have the trans version and the cis version of the alkene. The trans version has just barely slightly lower boiling point, but very, very similar. And the cis version has slightly lower than that. So that's pretty simple and straightforward. No drastic difference between them. They're still only dealing with dispersion forces, so it's a very weak interaction, relatively low boiling points. Of course, remember comparing this to water's boiling point of 100 degrees Celsius. So water is a very small molecule, but because it has stronger intermolecular forces, it has a higher boiling point than these. These all have similar intermolecular forces. The difference between them is really just about how well their molecules can lay next to each other, how well one molecule can lay next to another molecule and attract each other. That's pretty much it. But there's one wrinkle that comes in when we start adding different types of atoms. So the molecule could become slightly polar. So we can see that here. Here we're looking at butane. So this is, butene. So this is 4 carbons with a double bond in the middle. This is 2-butene. 1, 2, 3, 4, double bond starting on the second carbon. So we had the 2 different options for that, the cis version and the trans version, and still we have them pretty similar, what we would expect. But what I want to focus on over here is cis and trans isomers when we have a different thing attached, where here we have chlorines attached. Notice in the trans arrangement, the chlorines are sort of pulling opposite each other. So they make a more balanced overall electronic environment. Where in the cis arrangement, the chlorines are on the same side of the molecule as each other, pulling the electrons strongly toward that side of the molecule. So this one then would be more polar or more unbalanced in the way its electrons are shared around it. The negative, the partial negative, is going to be much more on this side of the molecule, and then the partial positive on this side of the molecule. And this one, of course, less polar. So anytime you have something being more polar, that leads to a higher boiling point. And in this case, because it's something like chlorine that actually has a much stronger electronegativity, you actually see a significant increase from 47.5 degrees Celsius up to 60.3 degrees Celsius. That would be even more pronounced if the groups were something like alcohol groups or something like that. So that's it. That's physical properties of alkenes.